Hello creators, welcome to the Creya class. Before we begin with the fun learning activities, let me give you short introduction about Creya class. Creya class is a design learning program wherein you will learn about 21st century skills like engineering basics, robotics, Internet of Things, animations and many more. This is basically a hands-on activity class where you will learn by doing, but because of this pandemic situation, we your teachers found out a new way to reach out to you so that you do not adhere to this conceptual learning. Here you will learn the concept of engineering basics by watching videos and images. Then by following instructions from Creya application, I will make models by using engineering constructibles, and the basis of that you will fill your logbook. Children, even you can also try projects by using material available at home. So let's get started. Have you ever thought of why a cricket bat is shaped the way it is? Or why we use hammers to hit nails? Or why we use scissors to cut things? How does a seesaw work? So, cricket bats, tennis rackets, and seesaws are examples of simple tools that make it easier for you to do something. They are called simple machines. So, children, simple machines are the machines that makes our life easy and comfortable. It does not require electricity even. There are 6 different types of simple machines: lever, wheel and axle, pulley, inclined plane, wedge, and screw. So, children, we are going to learn about lever. As you can see, picture on the slide, a lever has 3 parts. A lever is basically a rod that is fixed at a point. This point is called the fulcrum. Effort or force is applied on one arm of the lever. The lever then moves around the fulcrum so that the other arm can do some work. The arm is called the load arm. Why do we use levers? A lever is a simple machine, and that means it should make doing work easier. Let's watch a video and learn more about it.
Oh, see here what the gardener is doing.
He's trying to move a big stone with a rod.
Yes, this rod is called lever.
Oh, lever?
Yes, let me show you its different parts.
Lever? Hey, it is fixed at one point.
Yes, the fixed part is called fulcrum. And see, he's putting force with his hands. It is called effort.
What is stone called here?
Oh, it is called the load. Do you know there are many kind of levers?
Many types of lever?
Yes, see, fulcrum is on center here. And see here.
Oh, effort here is by the person.
Yes, but fulcrum is on the other side and load is in the center.
Yes, in first one, fulcrum was on the other side. And here, it is in the center.
Let me show you one more type.
Oh, here effort is in the center.
Yes, load is on one side and fulcrum is on the other side. Let's see one more kind of lever. Now, can you tell me where's the fulcrum on this simple machine?
Oh yes, it is the center. It is fixed.
And where the effort is put?
Effort is put from the back and load is on the front.
Outcomes of the video are: levers are simple machines that consist of a rod that is free to move about a fixed point. This point is called the fulcrum. The parts of a lever are fulcrum, effort arm, and load arm. I am repeating. The parts of a lever are fulcrum, effort arm, and load arm. Depending on the positions of the fulcrum, the load arm, and the effort arm, there are three classes of levers. Classes of levers. In a class 1 lever, the fulcrum is present in between the effort arm and the load arm. In a class 2 lever, the fulcrum is present near the load arm. In a class 3 lever, the fulcrum is present near the effort arm. See the difference of classes in the next slide. Here are the materials to make the block lifter. Here I have launched Creya application Open Grade 4 module levers project 1 the block lifter. Materials. First material is building block 30. We need 6 building blocks. This is hinged block tab. Next material is angle girder 30. Next material is angle girder 60. Here you can see there are two types of angle girder 30 and angle girder 60. Next material is building block 15 with 2 pins. As you can see, it has 2 pins. Again, there are two types of building blocks, building block 30 and building block 15. Next material is hinged block tab. Next material is mounting plate. Next material is building plate. Now we will start building a model of block lifter. We will click on the steps. First step is the block lifter that you are going to build has two parts, a fulcrum and a beam. Start building the fulcrum of the block lifter by sliding the pin of a building block 30 into the central groove of a bottom plate 30 by 90 as shown. So I am taking this building plate, in the central groove of a bottom plate I am attaching this building block 30 as you can see in the tablet. Now the next step is attach a building block 15 with 2 pins to the top groove of the building block 30. As you can see in the picture, I have taken this building block 15 with 2 pins and I am attaching it on the building block 30. Our next step is slide the groove of a hinged block tab onto the topmost pin of the building block 15 with 2 pins. Note the orientation of the hinged block tab. See the orientation of the hinged block tab. We have to attach this way. So I am attaching this on the building block 15 with 2 pins. I am sliding all the materials. Now our next step is fix a hinge block claw to the hinge block tab as shown. This completes the fulcrum of your model. We will learn more about the fulcrum later in this project. We have built the fulcrum part as I am attaching hinge block claw. So our fulcrum is ready. It is fixed at some point. Now the next step is to start building the beam of your model. Attach a building block 15 with 2 pins to the pin of the hinge block tab. The pin of the building block 15 with 2 pins should face the short ends of the bottom plate. As you can see in the picture, I have taken building block 15 with 2 pins, attaching it on the hinge block tab. Now it is also moving. Next step is attach 2 building block 30 in order to one pin of the building block 15 with 2 pins towards the near side of the bottom plate. So we will attach building blocks, 2 building blocks this way as shown in the picture. See how I am sliding all the material. Is it same as in the picture? Okay, let's move to the next step. Similarly, attach 2 building block 30s to the other pin of the building block 15 with 2 pins the far side of the bottom plate. I have taken these building blocks and I am attaching towards the far side of the bottom plate. So this rod is ready. Now come to the next step. Connect the groove of an angle girder 30 to the pin of the nearmost building 30 of the beam. This is angle girder 30. As I told you earlier, I am connecting the groove of a girder to the pin of the nearmost building block 30 of the beam. Let's move to the next step. Take a building block 15 by 30 with 3 grooves and connect the slide with one groove to the pin of the angle girder 30 as shown. So this is building block 15 by 30. I will connect this way as it is shown in the picture. Now move to the next step. Attach the pin of an angle girder 60 to the far groove of the building block 15 by 13 to 5 with 3 grooves. We have to see the orientation of the angle girder 60. This is angle girder 60. I am attaching it with the grooves. Move to the next step. Attach the pin of another angle girder 60 to the near groove of the building block 15 by 30 with 3 grooves. Your block holder is now complete. I have taken this angle girder 60, attaching it, and our block holder is ready. Now next step, now attach an angle girder 60 to the pin of the building block 30 on the far end of the beam. I have taken this angle girder 60, attaching it, complete the beam of your model by attaching a building block 30 to the angle girder 60 at the far end. So this is our final step to make this block lifter. You have completed the build. Now place a weight of 5 to 10 building blocks 30 in the block holder. This is the load that you need to lift. How are you going to lift this weight? Think of the beam of the model as having a left arm and a right arm. You can see that the block lifter is on the left arm. Since you keep the load in the block holder, this arm is called the load arm. An easy way to lift the load is to press down on the another arm of the beam. Since you are putting an effort in pressing down this arm, this is called the effort arm. So what is this effort you are putting to push the effort arm down called? As you may have already know, any effort that is used to push or pull object is called force. What happened when you applied force to press the effort arm down in your model? As you can see, I have placed a weight of 5 to 10 building block 30 in the block holder. This is the effort arm. This is the effort arm. This is fulcrum, which is fixed at some point, and this is load arm. We are putting an effort in pressing down this arm. This is called effort arm. Since you are putting an effort in pressing down this arm, this is called the effort arm. So what is the effort that you are putting to push the effort arm down called? As you may already know, any effort that is used to push or pull object is called force. You have seen that your block lifter has a beam and a fulcrum. The beam is just a straight rod that is attached to the fulcrum at one point. The fulcrum is the point around which the beam moves in your model. The hinged block claw and the hinged block tab allow the beam to move up and down. Since the block lifter is a machine that helps you do work, it is called simple machine. The block lifter is an example of a type of simple machine called the lever. A lever is nothing but a straight rod that is attached at one point and can move about the point. In the model, you have built the fulcrum. It is in between the load arm and the effort arm. Let's move to question and answer. Question number 1 is the block lifter is a class 1 lever. Label the different parts of the lever in the picture of the model given below. As you can see the picture, now tell me How many parts are there in the liver? Let's move to the next question. Modify a model by moving the fulcrum away from the load arm as shown below. Now try lifting the weight again. What do you notice? Let's try lifting the weight. So this is our load arm and this is, yes, fulcrum. I am moving the fulcrum away from the load arm as shown below in the picture. Now I am trying lifting the weight again. I am finding little bit difficulty in lifting the weight. It is taking more efforts. So what is the answer? Is it taking less effort to lift the load or it is taking more effort to lift the load? This is the arm, this is the effort side. So what will be the answer? Tick your answer in the logbook. Now move to the next question. Now modify the model by moving the fulcrum towards the load arm and away from the effort arm as shown. Try lifting the weight. Okay, so I am moving the fulcrum towards the load arm and away from the effort arm. So this is my load arm. Okay, it is near to the load arm as it is shown in the picture. Now I will again try to lift the weight. I am putting load in the block holder. Since the effort rod is much more longer than the left side, you can also observe that it is much more easier for me to lift the load.